All right, well, hello everyone. If you haven't met me yet, so I think I've met most or all of you now, maybe not to the online participants. I'm Simon. I work at Aarhus University, Denmark. I'm an educational or physics education researcher, and I'm also involved in the several quantum flagship CSAs in education and community building. So I'm here to talk to you a little bit about continuing filling in the gaps of where Oksana spoke. We've kind of done a two-parter because we work together very closely about how we've assembled the European education community and what it's going to do in the future, or what it might do in the future. So the first few slides you will have seen a few seconds ago, just to refresh our memories of where we are. Let's see. Yes, so up to now, we have this community building project called QTEdu. Oksana talked all about it, and it's been an amazing community building effort where we've brought together, on the website, there are now 410 members from 40 countries, I think, across Europe, all working together on really concrete innovations in quantum tech education. And the idea has been that we wanted to have this roadmap towards a quantum capable workforce. And the way that we've done that is through several things. This development of a common language for use in developing curricula and for looking at potential job requirements and things like this. We call this the competence framework, and Oksana talked to you about how it was developed using a Delphi study method. And it's still being refined over time, using data more from pulling in data from jobs and from courses as well. Then we had this idea of looking at what the individuals in the community actually wanted to do. So we brought together 400 people, and what they were really looking for in coming together, in collaborating, was, well, collaborations and development and research around educational activities. So these people really wanted to do things that they weren't able to do on their own. They were isolated, and that they could use the community to actually do concrete things. So what kind of concrete things could they do? Well, we had a structure for that as well. And well, we brought them together. We had these working group meetings. Zeki, you and Olga, I think you were probably there at some of these early meetings, where probably some of these are your notes on the Miro boards. And people brought together their ideas, and we structured these to promote synergies between the participants and to launch these pilot projects, which were intentional, driven community efforts. And they're all concrete actions which have resulted in real changes across Europe. So it's great that, Oksana, you talked about the school ones before, because I'm going to talk about two of these in particular today. But I just can't emphasize enough that we brought together people who were not necessarily able to implement things on their own because they were just working on their own, but they were all really passionate educators wanting to promote innovations and wanting to promote best practices, wanting to teach quantum in new ways or widen access to resources or any number of different great things. And they came together and they worked over the course of the year, completely voluntary, to promote genuine innovations. And they've been really fantastic. So you see this one on the top here was an outreach pilot led by Marilu, who you met earlier in the education session, and Zeki as well. And then these ones have been in the high school education that Oksana talked about to answer your question. And then this one, ITAS, is in the bachelor education, developing educational modules. And then these two, QTOM and Effect, have been in the higher education sphere in the master's programs, which has been something that we knew the European Commission was wanting us to work towards. It was written in the original QTEdu proposal that we would address master's education. So these were somewhat targeted towards being set up and future possibilities, which I will talk about later. And then finally, we have this quantum retraining network, which was in the industry lifelong learning. So they hosted events for companies to be teaching their staff about quantum. Okay, so very briefly, just to show you an example of the kind of concrete things that these pilots can do. This is the outreach pilot. There's Zeki and Marilu. And in the outreach pilot, they collated resources for different ways of outreaching quantum technologies to the public. So, for example, games, and so Quantum Moves is a game developed in Aarhus, where I am. Quantum Odyssey is a quantum computing sort of gate operations. Very, very cool, actually. I really recommend you download it. It's a fantastic game. It's in Romania. Qiskit, which of course we know from IBM. Quantum Composer is a quantum mechanics simulation tool that can be used to simulate actual Schrödinger equation and wave mechanics in a neat sort of drag and drop interface. So it's very nice for getting people introduced to it. And Zeki has written a paper about collating all of these. So yeah. There was also an RRI workshop. So Marilu talked about the importance of this, and in the pilot they piloted a workshop to use discussions and this game also that's made in ITFO, where you have to sort of predict possible futures of society based on different structural things around quantum tech. So, which is really nice. It's another one I recommend you look at, called the Decide game. There was a Delphi study. Zeki spearheaded this, where we wanted to find out what were the greatest challenges and opportunities in outreaching quantum tech. And we found out that the narrative is important, not encouraging misinformation, choosing exactly which topics. If we have a limited selection, what do we want to showcase to the public? What's going to be the most valuable? And what kind of tools can we use to make it accessible? And the pilot was able to address these because they collated a great selection of tools together, as I said in the paper. And then we addressed, through some pilot workshops, we addressed a storytelling narrative that could be a way to approach, or a more general way to approach this outreach. And that's there's a paper about this called Culture Over Scientific Storytelling, where we use some educational research, some theories around how different disciplines in physics are kind of like discursive cultures in the way that they're taught. And quantum science has its own unique culture, which we want to outreach. We want to be outreaching to the culture of the subject. So I'm not going to go too much detail about this, but it's just an example to show how one pilot, which is just one, and there were 11 of these, the deep level of concrete action that took place within them, completely voluntary. I said I would talk about the higher education sphere. And another one of these pilots was the Open Master, QTOM. And this was designed to widen access to really specialist areas of quantum technology. So you can imagine that maybe in University of Copenhagen, they might have a very strong focus on quantum information theory. Maybe they have a really top professor in quantum information theory there. But they might not have that in the university where many other students are studying their courses. So they're not going to have necessarily the same teaching expertise in these very specialist areas. So we said there has to be a solution for this because there are a limited number of quantum master degrees. At the time QTEdu started, there were very few. There's many more now, but even so, there's still not many, maybe 30 in Europe. So at the time, if you wanted to work in the quantum industry, you would do a physics degree, an engineering degree, or something like this. And the chance of you having a quantum information expert in your faculty, not so high. So we wanted to share these courses more widely, share the expertise of these people more widely across Europe, and partially also driven by the pandemic. Many universities were able to put their courses online. So in the QTOM, we set up an infrastructure for sharing of courses between universities. It's a kind of transnational master. And the idea is that you, as a physics student or an engineering student, would sort of take as one of your elective courses a quantum course from a very specialist institution. And that really upskills you, if you like, from a physicist to a quantum scientist, in the sense that you get to study these specialist courses. And you know, we were thinking also about the way that the degrees and the Bologna process wants students, and it continually wants us to be promoting flexibility for students in their education. And there's a lot more flexibility if you can choose a course from 20 universities as opposed to just from your own university. And so there was a platform set up, courses went available online, and then we had to address lots of different challenges, for example, in how their examinations would work, in how the exercise material would work, what would happen, registration for online students. And then the biggest challenge of all was ECTS credits for students taking courses in other universities. So you would go as a student in Aarhus, you take a course online in a different university, and then you'd somehow have to go back to your institution and say, I did this course, can I get 5 ECTS towards my degree for it? And sometimes they said yes, and sometimes they said no, and sometimes we had a battle with them to try to arrange this, and we learned a lot, and many people worked very hard in order to get a handful of students, and it wasn't a huge number, but a handful of students to do this. And we learned a lot, which we brought in forward into something I'll talk about later, the continuation of this project. And so we had to make concrete changes in physics departments. Some of them had meetings in different universities, and they changed their rules, some of them, or they found solutions for this. And there were 16 departments that had options that were not available before the pilot, but now are as a result of participation in QTEdu. And yeah, so we found out how these different accreditation mechanisms work, and we've also written up a paper about this. So where are we going here? So from the QTEdu master pilot, we knew that there would be these European calls for quantum technology master programs. In fact, they were for advanced digital skills in general. There was a 70 million euro budget for 7 advanced digital skills projects to be launched, education projects. So that was in artificial intelligence, in high performance computing, cybersecurity, and there was one of the 7 was quantum technologies. So we had already assembled this community, these pilot projects who had brought together the people to work on these topics, and the infrastructure, and we'd shown it could work. So we thought, can we structure a master's program for this project with real budgets? Because all of what we did in the pilots was without any funding. Now we can have 17.6 million euros. Can we do something really impactful? And with that, we structured an application for this DigiQ project with 24 partners, 20 of them universities. There will be 16 new or upgraded / augmented master degree programs in quantum tech. There will be 2 million euros budget for sending students for internships or for exchange semesters in different universities. Now, the way that we could have done this, and the way that probably some of the other 7 education programs that were developed would have been more conventional, would have been a joint master's program between, say, 3 universities. This is, you know, I mean, TUM and LMU, for example, they have a joint master's program in quantum tech. There are other examples, lots of them around Europe. And if you go to the Erasmus Mundus catalogue, the Erasmus Mundus projects are built in exactly this way. And you can find 178 European joint master programs. But in thinking in terms of responsibility and also inclusiveness, that would mean 3 universities coming together and structuring really carefully a single master program. That's not very open to the big community of 400 people that we assembled. So we wanted something that could be open for everyone. And so we said, right, how can we structure this program and make it so complicated that anyone can participate to any degree? And that's what we did. So we included these kind of core partners whereby their university is developing new master degrees from scratch and awarding this thing we call the DigiQ Master, which is a supplementary sort of certificate that goes along with their education, which is sort of a stamp from the flagship and from the commission to say that this is teaching quantum technologies in innovative ways. But really, it's their own quantum master. And then ditto, there are universities maybe with the same thing, also with quantum technology masters, but maybe there are structural reasons why they can't do quite as much innovation as some of the core partners. They will get less money and they will do some degree of innovating, but maybe not the same extent. So they might not call it a DQ master. There will be universities who are more about creating resources, which are shared among the others. And then there will be, so we have a couple of SMEs and research centers involved in developing also material. So we created something very flexible, which is quite different to the kind of conventional Erasmus Mundus method of building a master program. Yes. So to summarize it a bit more neatly, and just to say what we've been able to do, we will have these DQ modules where Oksana showed you before on the website how we collect resources on the QTEdu website. So it's something that the community has already been doing. But we will have now funding for developing these, lots more games, lots more simulation tools. Oh yeah, let's admit them. And they will be, we've been trying to structure ways for all of the material developed in this project to spill over to the whole community. That's been the whole core of the project. Because not every one of the 400 people can be in DigiQ, but much of what we do there could be useful for everyone. So all modules developed in the project will be translated to 3 languages and made available for everyone online for free. Then we have these courses, which are going to be digitally augmented using educational modules and shared among partners online in the QTOM Open Master sort of format that we trialed. And again, we will spill those over to the community. We'll allow them to go online for everyone else as well. Then there will be these networks, which curate a kind of social structure for the program. And this was based off another pilot called the Effect Project, which ran for a year, where the students had a kind of Slack channel between 25 students, a few lecturers, a few members from industry, and they had these monthly events. They had in-person summer schools, and it kind of created their own research and career network while they were still at university. So a really cool and also very exciting social element to the program. And we will have 5 of these in DigiQ. And then we have industry and research internships and exchanges with extensive travel funding, actually 2 million, not 1.6. And then for students, they get to participate, they get their master degree and they get this DQ Master flagship stamp on it as well. And the idea, as like I say, is everything will spill over to the community. So these modules that can be built into courses, this will be done in the program, but it will also be available for anyone outside of DigiQ to also use if you want to augment your own degree program. As you can see, we use the competence framework that Oksana talked about as a common language for framing this. So the idea is that we cover the full breadth of the framework with the different kinds of modules that are developed. And then we can have a map of the curricula of the university programs that are developed through this. And here's some examples of some of the modules. So for example, they have AI and augmented reality lab experiments in quantum tech that you can do remotely. Or this educational tool called Spin Drops, which is used for visualizing molecular dynamics. So using, again, the Schrödinger equation and things. So yeah, the idea is that we have these courses. This is the QTOM platform, which we will continue to operate and use it to spill over these DigiQ courses to the community. And there are still some open questions about this because the project is only just starting. So for example, we will set up module and course reporting requirements. First of all, to make sure that the courses and modules developed are good. we need quality assurance there. We also want to allow everyone to do educational research around these things, because if you remember back to that slide, I showed the profile of the community. Research was another thing that the community really wanted collaboration on. So we have to create some kind of open mechanism for bringing in research as well around these things. Something like, and I was inspired by the hop-on mechanism for the Horizon projects, but we need some kind of hop-on mechanism for modules and courses for people to participate in different ways, to come and say, I'm working educational research in the University of here, for example. Can I have a work with you and collaborate with you on these concrete things that are being developed? So we're still creating some of this structure. And then, only to mention it, but the industry training and lifelong learning pilot has also birthed another European project that I won't talk to you about because it's structured. It's a little bit less complex than DigiQ because it's a smaller program, but it's has had the same function. We brought together people, and they were able to pilot things that worked, and they were able to apply for funding for them. How long do I have, Seki?
You can.
Good.
Yeah, you have approximately 10 minutes.
Great.
But that is also including questions.
Okay, cool. So final thing then, I'll talk to you briefly about how we are sort of aligning these things with the flagship CSA ongoing, and how we have a way to control what spills over and what doesn't, and how we might adopt some best practices more widely in institutions around Europe. So Oksana talked to you a bit about this, but up to now, we have this QTEdu CSA until it ran until about September of this year. And there were two other CSAs as part of the flagship as well. There was this one, which was QFlag, which was looking after research and innovation and strategy, and they prepared all those strategic documents that Oksana showed you and things like this. There was this INCO QFlag, which was working on international cooperation with other quantum technology developing nations, and then the QTEdu for education. Then the CSAs have sort of combined together, and all that means really is that there will be greater synergy between all of these things. Education, workforce development, industry development, it's all one and the same, or it all leads to the same thing, which is supporting the EU's growth as a quantum industry. So this is something I would welcome some discussion about at the end of this presentation, is that it's the action that we'll be launching in March next year is the Virtual Quantum Training Institute. And we have created a kind of accreditation scheme. It's not a formal accreditation, but we have a system whereby we will be promoting this adoption of 6 principles in the field to universities and organizations across Europe, kind of institutional quantum readiness, if you like. And those are communication and outreach, so getting quantum technology out there for the public, diversity, equity, and inclusion, using standardization, so using the competence framework, that common language that we were talking about. We have organizational representation, so that's making sure that quantum technology is included in the governance of your institution. Teaching innovation, so novel and educational research-based ways of teaching. And widening access, sharing resources across Europe for the rest of Europe to use. It was somewhat inspired by accreditation mechanisms in the UK called Athena Swan and Project Juno. Athena Swan is a system which is signed up to by 400 universities, where they have to submit action plans for diversity, equity, and inclusion, and then their action plans are judged. And then they get awarded a gold, silver, or bronze award based on the quality of their action plan. And then there's a feedback and a review process. So we will be doing something like this in quantum technology, of education and workforce development. So we will give universities gold, silver, bronze sort of medals with a flagship stamp on the website. Might not show this one on a kind of platform that we will be launching in March. And this is a very simple mock-up of how it might look, where we can show how different principles are being addressed around Europe, and the organizations will be listed on the platform with the different showing you their action plans and giving them some recognition and some visibility as a kind of reward for adopting these best principles. And we can use it particularly in the context, this is a very messy slide, but we can use it in the context of education to be fostering didactic experimentation. So people say they want to try something and we say, that's great, go and give it a try. And then we find out what will work best and what doesn't. And those can go feedback into the principles that we have, that we disseminate. But it's an open discussion still. What exactly the list of activities or best practices, if you like, are within these topic areas, within these principal areas. And if anyone has ideas or wants to speak to me about it, feel free. I think it would be a nice thing for us to discuss a little bit. And I can also take any other questions about anything else as well.
Thank you, Andrew. So we can have questions.
There's a lot in the chat, by the way.
And yeah, I will check. Meanwhile, I will check the chat. So if you have any questions, please feel free to ask. And I see Nicholas has a question. No, just. I mean, I can repeat.
It looks impressive. My only question is, how do you communicate it to students? Because I think that it can get a little bit overwhelming because it's just so many possibilities and so much going on. Have you prepared some sort of package to communicate it to people who are studying within the programs, different programs?
So are you referring to the DigiQ master program there? Yeah, so within there's a lot going on, but a lot of that comes on the development side and the students don't necessarily see all of that. So from their perspective, they're enrolling on a quantum master degree at a university. So everything is as normal for them, except that when they sign up, they have the option to say, I'm going to participate in this network of students with the Slack channel and with the communication and all of this. And if you do that, then you also have access to travel funding for internships. And then some of your courses might be, you might be able to take courses from other universities, but they're not necessarily going to see all of the development work that goes into the module that's been built into their course. So that's more on the organization side, and it is a very large and very complicated project, but not all of it is on the students. A lot of, possibly more of it, is on the university, the teachers, the teaching staff. Yeah. Hey.
I agree, it looks very impressive. I have to admit, it's the first time that I heard about the master. I saw you also have and LMU involved.
Yes.
So just quickly mention what they do.
Yeah, so the MCQST, they have a quantum technology master.
Yes.
They will offer the DigiQ master within their master program. So students joining the MCQST master in a couple of years, they will be able to take courses from other universities. They'll be able to access internships. They will, the TUM and LMU staff will use the modules from other partners in their teaching courses. And so the functional effect is that there's still this MCQST master, but it's been digitally augmented. And that's the whole idea with DigiQ. So rather than being a single set program like these Erasmus Mundus masters, it's everyone doing their own thing and benefiting from everyone else's stuff.
Okay, but it's something that, because I'm actually doing the master program,
yeah.
So I was wondering if...
Oh no, the project only just started, so it will take a year or two to get there. It's a shame in a couple of years' time. Yeah.
So if anyone from our online audience has questions, please feel free to either write or unmute yourselves and ask.
I think you were first.
Yeah, question. Yeah.
Yeah.
So I was with my mind already with the topics of after the lunch. Do you notice the geopolitical changing landscape? Are the packages you offer open for everyone, or do you already see that there's kind of change there? So Chinese students.
Maybe can repeat the question. So the question was, do you see any change according to the developing geopolitical situations compared to, let's say, a couple of years ago?
Yeah, so it's access being limited. It's a fake question deliberately.
Yeah, no, it's we've encountered this blurred line, and I was speaking to Zeki a bit about it in the context of these pilot programs as well, in terms of how the EU money goes into developing structures which are open, and then there's a blurred line with when we say who can participate in these open things.
Yeah.
But maybe they no longer cost money from the EU to actually include people from other nations. But there was the EU money went into developing the structures in the first place, like this, or like the DigiQ master, or the pilot programs, for example. So this is still really an open question in the flagship about how much we can participate with kind of these international geopolitical difficulties. Certainly, yeah, I mean, it's not got any easier since, I mean, I felt it with Brexit, but it's not got any easier since the war and increasing tensions with China. So yeah, I mean, this is entirely European project, the DigiQ Master. This will be rolled out for universities across Europe. But whether people approach us from America and say, we'd like to work with you on this, we still don't necessarily have an answer to what we can say there.
Okay, so widening access is still that last bullet?
Yes, this is all within the EU. Yeah.
So my question would be EU or EU and associated countries?
Anyone eligible for Horizon funding, okay, would count. So they all count.
Okay.
Yeah.
Astrid, please.
So I understand that the programs are mainly looking at natural science, but when I look at quantum, it's a lot of times interdisciplinary. Yet at the same time, at least at my university, we experience that there is really a hard time to develop some co-working, like between physics and economic informatics or things like that. So do you have a spot in your program to answer those kind of obstacles?
Yes, we do. So some institutions are developing kind of more introductory courses, which are more aimed at bringing in, because these are master programs, bringing in maybe bachelor graduates from economics or bachelor graduates from different subjects. And yeah, as we have put in that there are organizations developing these things. And of course, it doesn't have to be every one of the 20 universities, because they're streamed online for the others to access. So if 4 of them develop these introductory programs, then all of them have access to them. Yeah.
So if there are no other questions, we can move to lunch, and then you can continue asking your questions to Simon while we're eating. And also he should eat. This is the Oksana. And well, thanks again.
Thank you. Bye-bye.